Great. So I have a request to do page 570, number 13 by an unknown person, but let's just say bruh. So what we're going to do is we've got this set up. So it's a cylindrical tank with a height of 15 meters and a diameter of 2 meters. It's being filled with gasoline at a rate of 500 liters per minute. So we got fuel pouring in at 500 liters per minute. And it says, at what rate is the fluid level in the tank rising? And then it gives us a ratio to use. Well, it doesn't actually give us a snapshot value, but that should give us some insight into exactly what's going on. Because it doesn't give us a snapshot, it probably doesn't matter what that snapshot is. So sometimes when you're curious, if it doesn't give you something and you think you might need it, maybe you can say, oh, well, I'm going to, even though it hasn't said, I'm going to say when it's at 10 meters. So, keep that in mind. So what are our givens? Well, our givens are going to be, well, this is obviously, it's a form of dV by dt. So dV by dt is 500 liters per minute. Okay, so that's what the form is. It gives us dimensions, so it gives us that the overall height is 15 and the overall diameter is 2. So I'm going to say that the diameter is equal to 2, and that means the radius is equal to 1. And the reason I'm going to say that is because what's interesting about these guys is they're static, right? Because regardless of how deep this water is, if it's a cylindrical tank, it's 2 meters here, it's 2 meters here, it's 2 meters here, it's 2 meters here. So this is static. And in theory, the 15 doesn't even really come into play until such time as the water actually fills the absolute max of the tank. And so the height, max is going to be 15, but the thing is that that doesn't really matter all that much. So let's look. So we know that volume of a cylinder is equal to pi r squared h. And because the radius, this guy here, is static, it doesn't actually make any difference in the grand scheme. Because it's static, I can substitute right now. So we have the volume of a cylinder is pi times 1 squared h, which is just pi h. And that's what the volume is equal to. So that's a pretty simplistic expression right there. It's pretty nice to use. And so we want to know, okay, so I didn't actually list my wants. I'll put them up here. So my wants, we want to know what dH by dt is, okay? And so I'm going to differentiate. So we're going to say that dV by dt is equal to pi times, in theory, 1 times dH by dt. So here's why they didn't actually give us any value, any number to substitute in. And that should kind of make sense, because if you're filling at a constant rate, it's going to be actually increasing its depth at a constant rate, simply because the amount of water it takes to go from there to there is the same as to there is the same as to there. So it's going to be a linear, very linear, or a constant depth change, so long as the volume increases at a constant rate as well. So dV by dt is 500 liters per minute, but it also gives us the proportion that it says. It's not all that useful, but it tells us that 1 liter is equal to 1,000 cubic centimeters. It's also worth knowing that there are 1,000. They didn't tell us this, but I know it. 1,000 liters is equal to 1 cubic meters, which is kind of crazy when you figure if you took a block that was simply 1 by 1 by 1, it would have obviously a volume of 1 cubic meter. That's a foregone, but it also has a volume of 1,000 liters, okay, which is staggeringly heavy if we're talking about water. But nevertheless, there we go. So we can use either of these, and obviously we're going to have to convert that, because dH by dt doesn't make any sense in terms of liters. If I said, oh, the depth of my whatever oil in my tank is increasing by 0.1 liters per minute, that's not a depth, that's a volume. So we need to convert this to a volume, or to a volume in terms of centimeters or in meters. So if it's 500 liters per minute, it's actually 0.5 cubic meters per